purpose of this little talk is to discuss the issue of scope. Scope of a variable, scope of a variable is the variable's lifetime. We need to know when are variables born and when do they die. And we also need to know, why is the issue of scope important? Well, let's begin to discuss that by creating a file, which I will call scope.py. Now, there's some useful little functions in Python, and one of them is this: print locals. All right, and we're gonna say I guess I hit enter to get that. Yes, okay. Print locals, print globals. That's something called kite, if you're interested in it, causing the autocompletes. Okay, so let's just have an empty Python file and do these two things and see exactly what's happening. Okay, you can see that globals and locals are the same, because when you type directly into a program and you're not inside of a function, you are right here, you are in the global scope. Things that are global are visible from the time they are created until the end of the program. They're visible throughout. Okay, so now let's go ahead and put some variables in here. Let's say x is equal to 5, y is equal to 14. And since we're in this global scope, let's see what we get when we run this. Okay, we're going to get a whole ton of stuff. All this infrastructure for Python, right? And then down here, so here's all the global infrastructure and the values it has. So there's a mysterious thing called double underscore name. It's main. And then there's all this other stuff. All right. Things we don't understand at the moment, but we'll gain an understanding of later on. But down here, when you come to locals, it's also going to show you X and Y. Now, X and Y are in the global scope of this program right now, because they're right out on the open. Okay, so now we're going to change this program a little bit. Let's get rid of these variables. All right, and let's make a function. All right, so we'll make our old friend square. All right, and what we're going to do is we're going to spy on square's inner life. To do that, I'm going to grab these two lines. I'm going to paste them in here and indent them. Okay, and you can see where a function ends is where the indenting ends. Okay, so in Python, whitespace is important. One thing I should mention at this juncture is it is very, very smart to do this. Go into your text editor's preferences and tell it when you hit a tab key, you want 4 spaces. If you do that, your life will be much better than if you didn't do that. Because if you have mixed tabs and spaces, Python has a hissy fit. And you want to prevent that, this is what you do. All right, so we're going to print locals and print globals inside of square. So I'm going to put a print statement that says print inside square. All right, and then down here, I'm going to say let's print when square is done, and let's call square so it actually runs. Okay, so the number 100 will print. when this function returns the number 100 will print. And we'll step through the code here line by line and see where the path of execution is going. Okay, let's see what we have here. All right, so here I'm running Python. Here are, wait a minute, oh yeah, here we can see the locals and globals printing out. All right. Oh, yeah, here's 5 and 14. See, there's the global variables printing out. Oh, let's go back in here. I want to look at what I did. Okay, so we're inside square. We're going to print locals and globals. So let's go back out. This is a little confusing. All right. So what happened? We're inside square, right? Here it is, inside square. We print the locals. X has the value 10 because we passed the value 10 to it in that print statement. X has the value 10, and here are all the global things. One of which is our square function is a function square, and it's parked at that memory address. Okay, so once that happens, locals, globals, function returned, and the value 100 is printed, and square's done. Then we printed locals and globals on the outside, and we see exactly the same thing because we didn't make any variables we didn't make any variables like define x equals 5 outside of any function. So the only user-defined thing we're seeing here is square, and square is a global quantity because it's directly in the file. Okay, let's go back in. So the lifetime of this variable x here, squares x, is not visible outside of x. Here's what we say about Python. The term the pros use. Python has function scope, and that means variables that you define are only alive for the function, or only alive inside that function. Now, one thing is, this is treated as a variable that only lives inside a square. Now, we could have done this. Let me get rid of the globals here, and let's get rid of this here because we're really concerned about what's going on inside of our code, inside this function. So we'll just print out the locals. But what I'm going to do before that, I'm going to make another variable in here called y. All right. And you will see, oh, let's go ahead and print locals out here. You're going to see that when we get down here, y is not visible, x is not visible, because their lifetime, they come alive when the function is called or invoked, and when the function returns, they completely and utterly disappear. So let's run this and see what it looks like. Okay, so here we are. We're inside a square. Here's the local variables, x and y. Here's 100. Square is done. And then down here we just printed the locals, which are the same as the globals. And you can see x and y are not visible out here. So when that function returns, it does a couple of things. It gives an output value, and it terminates the execution of the function and rings down the curtain on any variables created in that function. And you might think, well, that's sad. We're losing variables. Well, it's actually not sad. And here's a good reason why. We use this print function right here all the time. And if we had to worry about the local variables, the variables defined inside of that function and not conflicting with them, we'd tear our hair out. We'd have to have a big sheet of paper that said, in print, make sure you don't, if you're going to use print, don't use all these variable names. That'd drive you crazy because you might use dozens of different standard library functions and you don't want to keep track of all those names. That's why we have local variables. So Python has function scope, which, what does it do? It confines the lifetime of variables to their function. So when you make a variable inside of a function, it lives in that function, and when that function returns, it's gone. It's erased, it's wiped out. And that way you don't have to worry about the variable names other people use. And this is the reason I was able to get away with this. Let me get rid of some of these things here that we no longer need. All right. And when I did this, you didn't even think about it. Or times square of x. All right. You didn't even think about it. It just worked. And that's because different functions have separate what are called local symbol tables. And a local symbol table is nothing more than all the variables that are defined in that function and the values that they harbor. That's the local symbol table. And as a function executes, it builds line by line. Here I'll show you what happens when this code runs, just so you can see. When this code runs, square and cube get read into memory. Then it says square of 10. And so control passed to print, and print has got to pass it to square because that has no idea what square's going to do. And square's going to get this 10. So what is going to happen on this line, right here, is x is going to be harboring the value 10. Then on this line, what happens? The symbol table grows. X points at 10, and y points at 100. Okay, so that's the symbol table. When you make a variable, you're literally writing on a symbol table. And then when you get to this statement down here, what happens is y, we know what y is because we can look it up on the symbol table. It's 100. It says return 100. And when you do that return statement, all of this stuff right here, yeah, come on, Vim, do what I want, gets destroyed. It's all gone. Okay? Now, to be a little more technical about this, let's think about the way Python stores variables. What Python is actually doing when it sends 10 up here, it's actually sending the memory address where 10 is being stored. So that memory address is in here, but Python knows how to fetch things by their memory address. Okay? So a copy of this memory address where 10 is stored goes here, and then this gets used, and then all that stuff that's inside of there goes away. So you, as a user of Square, do not have to keep track of the fact that Square is using the name Y. It simply doesn't matter. What matters is the behavior that the function has. And this is the idea of scope. So scope allows you to keep the lifetime of variables short. And here's what I would say about scope. There's something called the Blofeld Principle. Blofeld was a villain in James Bond movies. If you've never seen any of the Blofeld movies, my favorite involves his demise, and For Your Eyes Only, it is a hilarious scene. But Blofeld would say to some henchman, "I'm afraid you've outlived your usefulness." And the Blofeld Principle of programming says, never let a variable outlive its usefulness. The fewer variables that you see, the less confusion there is, and the less possibility there is for conflicts, which can be very difficult to ferret out and resolve. So, fewer variables is like driving in light traffic, where all the cars are moving at expressway speed and there's plenty of space between everybody and nobody's smashing up their cars or getting too close to each other, and life is pleasant. Okay? Scope helps keep things manageable. A human being can only focus on a few things at a time. And what we do in computer science is we wrap things inside of other things. So you have a square is now like this procedure that we can just pass a number into and get the square out of and not care how it happens. Now, square is a particularly simple thing, but there are lots of functions that are quite complex that all you worry about is what are their inputs, what are their outputs, and what are their side effects. And scope is what keeps it all manageable. So keeping scope short is smart. If you want to learn about what's in scope and out of scope, you now have some tools. You can print locals and you can print globals and you can see what's going on. And it's a smart exercise is to write yourself a program and spy on its functions and see what they're doing. Because then you can learn more about how the language actually works. Okay, next time what I'll talk about is something called the call stack and how this regime of local variables is actually enforced by Python. So see you next time.